Ladies and gentlemen, this is Tolbert's class, Chapter 4, Lesson number 2. So we've already covered position, speed, and velocity. Now we're going to be covering various different graphs of motion. The final lesson in this particular series will be acceleration. This is lesson number 2, Chapter 4, Lesson 2, Graphs of Motion. So, some of the learning goals for this particular lesson is for you to be able to construct and analyze graphs of position versus time, and also speed versus time. I want you to be able to recognize and explain how the slope of the line describes the motion of the object. You should be able to look at a graph and tell me, well, what is exactly happening as this person is moving as described by this graph. And you should also be able to explain the meaning of what constant speed is. Let's go ahead and start with constant speed. Constant speed means that speed always stays the same. It's constant. An object moving at a constant speed creates, during a position versus time graph, a straight line. Here's what this looks like. Position is on the y-axis. Time, as always, is on the x-axis. Because it's a continual change, you'll notice that it's not curved. It is a straight line. The data shows the runner took 10 seconds to run each 50-meter segment. Here's kind of what this looks like. This is a different type of graph. In this type of graph, I have speed on the vertical axis or the y-axis and time on the x-axis. Notice, this is a particular slide that is denoting the importance of, or the concept of, constant speed. Speed is the same. Notice here, this speed is 1 meter per second, and it's not changing over time. It's constant. But you can look at a couple of things in this particular example. Let's try some other things. Like, for instance, if I were to put a dot here and put a line here, this would also signify a constant speed. But notice, this is 2 meters a second. So you can look at this and compare the difference between these two lines. You can say that this upper line is traveling faster. Yes, it's a greater unit, but it's also traveling faster per second. Let's look at these various graphs. In this particular one, you can see, like I showed you before, where we have several different lines here, and you should be able to extrapolate the fact that this higher blue line is traveling faster. But let's look at this graph over here. Notice the slope of these lines. This is still the blue line. As we said, this speed here is faster or more, so notice that this is a steeper slope. It is a steeper slope. The steeper the slope, the faster it's moving. So let's go ahead and note that. You can use a position versus time graph to compare the motion in different objects. The steeper the line on the position versus time graph means you're traveling faster. What are we talking about when we're talking about slope? When you're talking about slope, you look at the various axes. You have the vertical axis, the y-axis, versus the x-axis. To find slope, you're going to use this formula, or you've used it before, rise over run. Okay? Rise is the y-axis, run is the x-axis. You're going to count your units, or the amount that's on your rise. In this particular example, it's 600. In this particular example, my run, or my horizontal axis, is 150 seconds. I'm going to put these together. 600 meters divided by 150 seconds is going to give me a speed of 4 meters per second. The slope of the line in a position versus time graph gives you the speed. Here's another example of that. Objects rarely move at a constant speed, though. Sometimes your graph can show that something is speeding up, and sometimes your graph can show that you're slowing down. And remember, the other example was constant speed. So I'll just draw an example of constant speed up here. You've got to pretend like this is a graph. Remember, our constant speed was a flat line. And this is all versus the speed versus time graphs. The flat line here is constant speed. This here is speeding up. This one here is slowing down. Graphs of motion, changing motion. On a graph, the length is equal to the time and the height is equal to the speed. Here's a great example. Remember when I was talking about a constant speed? Constant speed is a flat line. We're also going to be getting to acceleration. Acceleration tends to be a sloped line, but it can be sloped in the positive or the negative fashion. Alright, so that is the end of lesson number 2. I hope you enjoyed this lesson.